सर।
हेलो।
सर मुझे एक क्वेश्चन पूछना था।
हाँ बोलिए।
सर हमारे टोटल नंबर ऑफ असाइनमेंट्स 18 है ना?
टोटल नंबर ऑफ प्रैक्टिकल्स आर 18।
मतलब वो जो असाइनमेंट बुक आपने दी है, वो मैनुअल प्रिंट करना है, उसके वो
हाँ,
असाइनमेंट
दैट इज
7 ही है?
प्रैक्टिकल लिस्ट ऑफ एक्सपेरिमेंट, नॉट असाइनमेंट्स।
वो 7 ही है क्या फिर?
नो नो, दैट इज ओनली पार्ट ए।
ओके
That
सर।
7 is part A. There is part A, B, C in your syllabus. So that part A and part B today we will complete. Part A is the test on the cement, on cementitious material, and part B is the test on the filler material, the fine and coarse aggregate.
ओके सर।
Okay. We have total experiment and all the experiment of filler material test on the filler material, the fine and coarse aggregate we will try to complete today, and then only remain will be the test on concrete. Already in classes we have seen the test on concrete as slump test, slump cone test, and maybe consistometer test. Also compaction factor already I have explained in classes. That is the test on the press properties of concrete, the workability of the concrete. Now today we will see the test on the coarse aggregate. And will we start? Are we ready? So total yeah, manual I will send you soon. Okay. This part A just I have sent you earlier. Now part B is the this list of test on the fine and coarse aggregate, and part C test on the uh, concrete. That index I already shared with you, but corrected one I will share with you the total manual, and then you have to print that and you have to submit that with the question answers. Okay. So we'll already seen this in last practical class experiment on the determination of specific gravity, water absorption, and bulk density of your fine aggregate. Today we will see the experiment number 11, that is the test on the coarse aggregates, and that is experiment number 11, which is the fineness modulus, the sieve analysis of gradation of coarse aggregate. The objective of the experiment is nothing but to determine the particle size distribution of coarse aggregate by sieving or screening. So at the end of this practical, you will able to know the understand the importance of particle size distribution. Why we are doing the particle size distribution, and why IS 383 emphasis on it. Also, you can able to decide the grading of coarse aggregate, how you can uh, grade the aggregate by different sizes. Okay, and ability to sew coarse aggregate. Also, you will get a knowledge and ability to arrange the various ISU as per the goals. So in this case, you need a coarse aggregate and the ISU based on the IS 460/1962. You need the boarding trowel, you need balance, and you need the stopwatch for this practical. These apparatus you need. The grading refers to determination of the particle size distribution of aggregate. And why we are doing the grading? Grading is when we have to get full compaction of your aggregate. So that help the you will next particle size will fill the gap of the above particle size. That's why the grading is very important, or particle size distribution is very important. The maximum aggregate size are specified because grading and size affect of the amount of aggregate used, as well as cement and water requirement also depend on this filler material, coarse aggregate and fine aggregate. Also, it affects the workability, pumpability, and durability of concrete. In general, if the water-cement ratio is chosen correctly, a wide range is grading can be used without a major effect on strength. When gap grading is specified, certain particle size of aggregate are omitted from the size of quantium. So if any single size of particle is missing from that, that is said to be gap graded. The gap graded are used to obtain uniform texture in exposed concrete, and close control of mixed portion is necessary to avoid segregation. So all particle size should be present in the concrete, and that will be from, if you are using 20 mm aggregate, then 20 mm, 10 mm, 4.75 mm, and next particle size should be available. 16 mm and as well as 12.5 mm also C are there. So these are the ISU based on the Administrator 460/1962, and you can see this ISU you can arrange like this. At the top the 80 mm aggregate, sorry, 80 mm ISU, then 40, then 20, and then 16, then 12.5, then 10, and then 4.75, and then fan. And this is the observation table. After the SU, we will fill this observation table, and then you can able to find out the fineness modulus of coarse aggregate. The grading of coarse aggregate is to find that the grading is as per the IS 383 table. This table is given by IS 383. If you are using 20 mm size of aggregate, you can see in this picture, if you are using the 20 mm of aggregate, 20 mm size of aggregate, then the ISU should retain 20 mm aggregate 95 to should pass 95 to 100% 20 mm aggregate from 20 mm ISU, and 10 mm ISU that will pass 25 to 55 percentage of your aggregate. The percentage passing of graded aggregate, this column for 20 mm we are taking here by weight, okay, and 4.75 it is 0 to 10%, and 2.36 should be nil, okay. So likewise from this table you can, if your range matches with the your grading, you have done the grading here, for 20 mm passing percentage. With this passing percentage, it is matching with the your Indian standard table, this IS table. Then you will say that your uh, uh, aggregate is well graded. If it's not matching with that, if there is gap of any one of the particle of 10 mm missing, then you will get that gap graded aggregate. Or if single size aggregate is available, then it is said to be a non-graded aggregate. So that's why the grading of aggregates are very important to fill the voids in the concrete. And if well compacted concrete is there, the strength will be good enough. So how we will do this procedure? We will see online. We will search the grading of coarse aggregate. So to explain the uh, on the sheet better, that you will see the video on the grading of coarse aggregate. So there are many videos are available. You have to choose that one will be the best. So sieve analysis of coarse aggregate. We'll see this video. So write down the process how to perform this. Uh, you'll see the how the coarse aggregate particle size are determined. So they are the apparatus required for the sieve analysis. So we are taking the 20 mm size and last span. This is the observation scene and then fan. So column 2 is for 3 sample, and then average of that will be recorded in column 5. Then we will calculate the percentage of total weight of retained aggregate. Then we find the cumulative percentage of total weight retained. Then percentage passing. We just try to join on time. Huh? This is not good. Now we'll perform the experiment. We'll take 1 kg of coarse aggregate sample, 1 kg or 2 kg as per uh, your sieve size. If you're using a smaller size, then you can take the this 1000 gram or 1 kg of sample you are taken, and then first sieve is your 20 sieve, plus 20 aggregate. Larger particle will be on the, then we'll do the sieving. Sieving can be done by the hand or the sieve shaker machine, so that it will be rotated from horizontally, clockwise, anti-clockwise, left, right, upside and down is vigorously, and then we have to zero on 20 sieve, then 50 to ground. Now the 12.5 sieve you can measure. All the readings are recording. Then the sieve size of 10 retain on the 10 sieve. These are the aggregates. Also the 4 point retain on the 4.75 sieve. All the weights are recorded. And then you should find out the last, the pan, how much the weight of that core aggregate particles. The pan that is also recorded and measured. These are repeatedly done for the two another samples, and then the same procedure will be done. Then the observe value, you have to find out the average of all the values for the three samples. 0, 47.3. Then you have to find out the percentage of total weight retained. Percentage of total weight retained is 47.3. Uh, Total weight of aggregate 1000 gram divided by 1000 into 100 will get 4.73 percentage. That is the weight retained. Then 494 gram, 12.5 aggregate percentage retained. You can find out by dividing 1000 gram you have taken into 100. This percentage weight retained will become. Similarly, you have to find out for each CO, you have to find out the percentage retained. Then you have to find out then percentage weight retained cumulative by adding this 0 plus this is 0, 0 plus 4.3, 4.37, that is 4.73% on 16 mm. All the cumulative percentage weight retained you have to find out in this column, and then last percentage passing can be calculated by because 100% passing at the 20 mm aggregate, and 100 minus 0 is 100, and then 100 minus 4.73 you will get 95.27 percentage passing of 16 mm aggregate. Then for 95 minus 54.13 will get 45.87, and then likewise for each sieve you have to uh, percentage passing you to find out, and then the observation till at the end the percentage passing at the pan will come to 0. These are the percentage value for single size and for the graded aggregate. These two table I have attached with your manual also. So this is from, you can see, sorry, here your manual. This table I have given for single size of 20 mm aggregate what will be the percentage, and for graded aggregate what will be the percentage. The different values are given. Based on value you can say that the single size of the graded aggregate is there. So that column here, the same column here, you can see by this column is given by the IS 383 1970. Okay, so based on this column you will compare your percentage passing, and that will give you the graded aggregate or single size aggregate as per this column. Here you can see this is the 20 mm passing, this is the 16 mm. Okay, but you can see here the percentage is matching with the single size aggregate. So you can, at the conclusion you can write down the grading of coarse aggregate, singly graded or coarsely graded. Okay, likewise you have to perform the, you have to compare your value passing percentage with the standard value or the value given in the IS 383 1970 or 2016. So this is what all about the your grading of coarse aggregate is practical. This is nothing but the procedure for the SEW analysis of your coarse aggregate. Okay, so you can, here you have to do, you have to write down, you have to add this 20 mm aggregate, 16 mm aggregate, 12.5 mm ISU, these are the SEW size, and then weight retained on each SEW you have to write down, then percentage weight retained you have to find out, then percentage weight passing and cumulative percentage passing, and based on this percentage passing, this this column will give you the grading of aggregate is singly graded or well graded. You can find out from these two tables, that table in IS 383 given, and then from the cumulative percentage passing you can find out the fineness modulus of your aggregate, and that should be write down in here. If this coarse aggregate is matching with the column, this column, then you can say that the well graded or graded aggregate is there. If it is not matching with this column, it's matching with this column in IS 383, in which case the single size 20 aggregate is there. So that is nothing but the practical for the sieve analysis of coarse aggregate or grading of the coarse aggregate. Now you have to do the calculations here, sample calculation, then you will draw the conclusion, and then you have to write down the question itself, state the meaning of grading of aggregate. What is the meaning of grading of it? Why should aggregate be dried before sieving? Give reason, state the meaning of what size of aggregate, how the size of aggregate affects the fineness modulus, how does the grading of aggregate affect the water requirement of the mix. So these are the different questions based, it will be asked during your term work submission. So you should uh, go through or each experiment and write down each question answer uh, at the space provided to you in the manual. And if the space is less, then you can attach the sheet, additional sheet, and write down there. Now will come the experiment number 12, that is the determination of specific gravity, water absorption, and density, that is bulk density of your coarse aggregate. In previous example, we have seen the fine aggregate, but here now we can see the uh, for the coarse aggregate. So there we have used the picnometer, and here you can use the wire bucket for to find out the particle size greater than 10 mm. So generally coarse aggregate we are using 20 mm, 25 mm, 40 mm, also 12.5 mm if high strength concrete is required. So that's why the different sizes of aggregate we are using in concrete. So we should know the specific gravity of the coarse aggregate or relative density, water absorption, that will affect the uh, fresh and hard and state properties of the concrete. Also the density of the coarse aggregate we need to know by the bulk density, and it is very simple experiment can perform. So this is the experiment to the objective is to determine the specific gravity, water absorption, apparent specific gravity of the coarse aggregate. Uh, After this practical, you will able to you are competent to understand the bulk density of coarse aggregate sample. You will understand the water absorption and moisture content of the coarse aggregate, ability to perform the test on coarse aggregate. Also, you can able to understand the specific gravity of the your course. These are the definitions, and uh, so these are the definitions for the bulk density, etc. You should note down that many disturbances are there. Our design, tricky, you are joined late. Go on to that, you should join on the time, and you are affecting the practicals. Okay, so this is nothing but uh, you have to do for the uh, find out the force aggregate, have a specific gravity, water absorption, and the density. So theory already we have seen the uh, during the fine aggregate. So that is specific gravity is nothing but uh, the the weight of or mass of the uh, material with is the ratio of mass of the material uh, to the same uh, mass of water. It is said to be a specific gravity. So it is a ratio mass of solid in a given volume of sample to the mass of an equal volume of water at the same temperature is nothing but the definition of your specific. The specific gravity of an aggregate is considered to be measured of the strength or quality of the material. Stone having low specific gravity are generally weaker than those with higher specific gravity. So that is also the bulk density of aggregate is the mass of aggregate required to fill the container of unit volume. It is expressed in the kilogram uh, per liter. Expressed in the kilogram per liter. Okay, so this is nothing but in water absorption. The water absorbed by the aggregate is the water absorption and saturated surface dry condition. If the pores are filled with the water but the surface is still seen dry by naked eye, it is called as SSD condition. As explained in previous practical, what is the SSD condition? Again, I will show you that this is your aggregate particle with the pores on the surfaces. Okay, the water is present inside the pores. If you can see, the water is present inside the pores. The water is present here. Water is present inside the pores. But the surface of aggregates seen as a dry, and then this condition is called as SSD condition. That is saturated surface dry condition. Now for this experiment, you need a setup like this. This is a weighing balance with rope. Okay, and this is wire basket. You can see it's suspended from the weight machine, and this is the bucket where the water is put because the sample should be immersed in water. If you take a weight a basket with in aggregate in the water, then this basket is weight under this water. So weight of empty basket in water also you have to take. That's why this basket is required with the water. So apparatus are generally wire basket that is perforated, then electroplate plated or plastic coated with the wire hangers for suspending it from the balance, in watertight container for suspending the basket inside, and dry sharp absorption cloth of size 75 centimeter by 45 centimeter. Two numbers are needed. Shallow tray, minimum 650 square centimeter area. Airtight container of capacity similar to the basket and oven. These are the apparatus we need to perform the specific gravity, water absorption of the your coarse aggregate. Now we will see the procedure how you have to perform this, and then later you can do the calculation for that. So we'll see here once again the uh, the specific gravity of how to find out the specific gravity of your coarse aggregate. Specific gravity of coarse aggregate. So this you can see from the please watch the video carefully because this the properties of your specific gravity of the concrete is depend on the strain as well as thermal expansion and reduction of the coarse aggregate. You can see the how this procedure is performed on the given sample of coarse aggregate. Okay, now we need oven, we need a gas vessel, Airtight container we need. Also, also we need the ISU. Taken 20 aggregate. It will be passed. So 1 kilogram of sample you can take. You can take 1 kg or 2 kg of the aggregate. Generally, we are taking the 2 kg of aggregate for this sample. Then you have to sieve the sample on 10 ISU because the particle more than 10 you are taking for this test. You can see the this is the aggregate you have taken for the so this aggregate now you have to put on the you have taken the you will see the procedure and then we will discuss. You can see in the manual the procedure for the specific radio coarse aggregate. This can be find out. You take the sample 2 kg sample of the aggregate. It is thoroughly washed to remove the final particle and dust. Drain then placed in the wide vacuum immersed in the distilled water at a temperature of 22 to 32 degrees with the cover of at least 5 centimeters from top of the basket and the bottom of the basket. Immediately after immersion, the entrapped air shall be removed from the sample by lifting the basket containing 25 ml above the base of the tank, allowing it to the top 25 times at the rate of about uh, 1 drop per second. The basket and the aggregate shall remain completely immersed during the operation and for a period of plus minus half hour or 24 plus minus half hour afterward. Then the basket and the sample shall be jolted and weighed in a water for a temperature of 32 degrees Celsius up to that is the weight A1. Then the basket and aggregate shall then be removed from the water and allowed for drain for few minutes, after which the aggregate shall be gently emptied from the basket onto on the dry cloth and the empty basket shall be returned to the water and weight of water that is W2. So here something different there is explaining and uh, this we have to dry the sample in you are bring the sample in a SSD condition. Now you have to weigh that sample, weight of sample in SSD condition. So you have to take the samples to bring SSD condition. Then you have to record the reading in the SSD condition. Different course having different procedures. So these are nothing but, this is the basket. Then you have to measure. Now again, this is the aggregate to transfer the basket. Again, the twisting is done, and air balls are reborn. Record the summer weight of the aggregate with basket. Then again transfer the aggregate to the ball. Then you will transfer. Then you have to record the dry weight of aggregate. So this is the procedure of to find out the specific gravity water absorption of the coarse aggregate. We will come another now for our manual how we can do the procedure in our case. Uh, so we will take a sample not less than 200 gram of aggregate that is thoroughly washed from the water and remove fine particle and dust, drain and then place in wire basket immersed in the distilled water at temperature of 32 degrees Celsius with a cover of at least 5 centimeters from the top of the basket, totally immersed in the water. Then immediately after immersing, the entrapped air shall be removed from the sample by lifting the basket containing 20 mm above the base of the tank and allowing it drop 25 times at the rate of 1 drop per second. The basket and the aggregate shall remain completely immersed in the water. Okay, and then this shall be brought to the room temperature, and then you have to measure the aggregate and basket in a water. The weight is recorded, that is, the basket and the sample shall then be jolted and weighed in the water at a temperature of 22 and 22 to 32 degrees Celsius recorded. That weight is nothing but A1. In the basket as aggregate shall then be removed from the water and allowed to drain for a few minutes, after which the aggregate shall be gently emptied from the basket on the dry cloth, and empty basket shall be returned to the water and the weight of basket in a water is taken, that is weight A2. Then the aggregate placed on a dry cloth shall be gently surface dried with the cloth. Transfer it to the secondary dry cloth. When the first will remove no further moisture, the aggregate shall then be wet, and that is nothing but D in the SSD condition. Then the aggregate shall then be placed in the oven in the shallow tray at a temperature of 100 to 110 degrees Celsius and maintain this temperature for 24 hours, and then remove the sample or shallow tray and cool in the airtight container. That aggregate cool in the airtight container, and weight C is taken. So this is the different weight you have to take, and then write down the weight here. The weight of basket in water, weight of empty basket in water, weight of saturated sample in a water, A, that is A1 minus A2, then weight of saturated surface dry aggregate in a air, and the weight of one dried aggregate in a year, that is C. All this you have to find out. But you can write A, B, C, D as required. So likewise, you can find out the uh, particle size. Okay, then using this formula, that is A, B, and C, you can find out the specific gravity of the aggregate. Okay, the naturally specific gravity aggregate and water absorption and bulk density is nothing but net weight of aggregate divided by the capacity of container in liter or the volume of container. The volume of container it gives you nothing but the bulk density of your aggregate. So likewise, you can find out the specific gravity and water absorption of the aggregate. Also, the bulk density you can find out for fine aggregate and uh, coarse aggregate. It is nothing but the weight of aggregate and density of aggregate. I will write here. Bulk density of aggregate. So this you can perform the experiment of the bulk density of aggregate. It is very simple estimate. Just you have to take the container and you have to fill the aggregate into the container. After filling each layer, in three layer you have to fill the container and each layer is say the compaction for the 25 times. So each layer is compacted for 25 blows and the container is filled for in a three layer. Then it will be leveled and the weight of container is taken. Also you have to fill the then again strike through the material over the surface. Then weigh the container. Measure the mass of the cylinder containing compacted aggregate. The aggregate weight divided by the volume of the container it gives the bulk density of the container. So this is very simple experiment you can perform on the fine and coarse aggregate by different containers and that bulk density is recorded that net weight of aggregate whatever it may be divided by the volume of the container it will give the bulk density kg per cubic meter of that. Then you have to write out conclusion the specific gravity of coarse aggregate water absorption as you have calculated here. From this calculation you can write down the values in conclusion here and uh, that's the lab work, that is a specific gravity or density of coarse aggregate can be find out. So that is then the question answer you have to write down. State the effect of bulk density and water absorption of coarse aggregate on composite strength of concrete. How the water absorption aggregate affect the properties of concrete. All this you have to write down answer on the space provided. If the space provided is less, then you have to take the additional sheet so that your question answers are completed. So this is till now we have completed the experiment on the cement and filler material fine and coarse aggregate. So this is from you can see the from manual from first experiment to experiment number one, the fineness cement by dry sieving, then again fineness of fly ash by wet sieving, then we find out the standard consistency of cement paste, then we find out the setting times of cement paste, initial setting time and final setting time, then the determination of soundness of cement by calorimeter, just only demonstration this experiment we have done, then determination of compressive strength of cement by preparing a cube with the standard cement mold of size 70.6 by 70.6 by 70.6. Then using plain air permeability apparatus, uh, how to find out the uh, fineness of cement in terms of a specific surface area, and then fineness modulus of C1 analysis of fine aggregate experiment number 8 we have done, and then experiment number 9 silt content we have done, experiment number 10 that is specific gravity and water absorption of the fine aggregate the particle size less than 10 mm, that is using technometer we have done, and then we have also completed the reverse analysis of generation of coarse aggregate today, experiment number 11, and in experiment number 12 we have completed the specific gravity, water absorption and density of coarse aggregate uh, on experimentation. These experiments we have completed till date. So I will provide you the uh, one by one reading. You can write down, and I will share you the manual uh, today or tomorrow. You have to print the manual, and then you have to complete all the practicals. Okay, so that is the thing, but you have to do. So we'll start from the first practical. So you can write down the readings as per sample 1. If you have taken 100 gram of sample and the weight retained on the sample is 3%, 3 gram, then 3% is the uh, your then second sample you have taken 100 gram and percentage retained is 4 gram and 4% retained. You have taken 100 gram of cement and the percentage retained is 6 gram, that is 6% retained, and average of this is nothing but 100. Average of this one is can do that is 4.33, I think so. You can do that average, you can find out by the calculating. 3 plus 6, 9 plus 4 is 13, 13 divided by 3, 4.33. The percentage of your average percentage of fineness of your cement is, or your unfined cement is 4.33%. So sample calculation you can done. You done sample collection for R2 sample. Then W1 is 4, W2 is W is 100, 4 upon W into 100 is 4%. Fineness of given sample of singing is you can find 100 minus 4.33%. Okay, 100 minus 4.33 whereas the fineness of sample is now you can write on 95.67%. So this is the conclusion for that. Then you have to write down the question answer on the experiment number 1. Then experiment number 2 is the wet sieving of the aggregate. Here also you have to write down the weight of the fly ash sample you have taken and weight of fly ash retained after wet sieving of 45 macron dried in oven and percentage it retained, that is write down, and then that will be compared with the standard value. This reading also you can I will give to you. Then the determination of standard consistency of cement paste. This value already in experiment number 1, this value already given. Now standard consistency of cement paste we will find out that experiment also we have done, and reading on the experiment number 3 video you can get from there, and all this reading you have to fill on the manual as given to you. At least you should write down the question answers, and then I will release a quiz on this experiment, and you have to complete the quiz, and then based on that quiz you will get the marks, and the marks will be recorded. Your assessment will be done on the basis of this uh, term work. Assessment will be done. This your attendance record out of 10 marks, instant marks out of 10 marks, quiz 1 and quiz 2, 10 marks, total quiz marks 20. Then the student performance, their oral answer, etc. for 10 marks. Its behavior also considered, student behavior also considered here. And then total marks will be 50. And then 50 marks is converted for 25 marks, and then final marks, that is round value will be written here. So that is the nothing but your term work assessment be done. Likewise, so all students should note that how the term work assessment will be done. Okay. So in 1 to 3 days, I will release the quiz. You should answer the quizzes, and that will be for your assessment. So thank you for this. You should do in a notice not came from department, but I will release the quizzes. You should complete the practical, and those students they will complete the practical only. They will be considered for the term work assessment. So this Agarwal is available, Momin Zainab is available, Ibrahim is also there today, More is also there, Abu is also there, Sabela is also there, Shar is also drawing today, Khan Irshad I don't know, Muhammad Azhar is not, Muhammad Saleh not seen today, and then Saeed Raza with Kamal and Salim Musnab is also there. Isari Muhammad Yasir. Isari Yasir is also there. Malik Shakil, Umar Farooq, Rizwan Ahmed Nursi, Umar Farooq. Then Ali Sumit is also not seen. In practical hours, in lecture hours they are there. Shafiz is there. Muhammad Ahmad is also joined today. I think not seen. UP is there, Gola is also there. There's some other things also. Yogesh is there. And the Mughal 68. Yogesh Singh is there. Then Mughal is also there. Mughal Shingini is also there. So you have to complete the very good work today. All the time you have to complete. I will try to send you the manual today. You'll print it, complete it, and then when there is homework submission, it may be physical or it may be online, whatever it may be. Your assessment procedure is like that, and you have to complete all the tasks as per the attendance is recorded for today's lecture. 3 June.
एक्सक्यूज मी सर,
हाँ बोलिए.
सर ये जो क्विज रहेगा उसके लिए प्रैक्टिकल की स्टडी करना होगा या जो थ्योरी लेक्चर है उस पे से स्टडी करना होगा?
It depends on your practical and theory both.
Like
Because without theory, huh?
completely whole subject we will have to prepare.
Oh, you have to prepare whole subject. Yes, it may be. Uh, there is
Sir,
already
वो
3 parts.
ये
Part A, B, and C in your term work. As I have given you index, so you can see in index. हाँ बोलिए क्या बोल रहे हैं आप?
ये बोल रही हूँ कि क्विज 1 है, क्विज 2 है, तो आप सिलेबस को डिवाइड नहीं करेंगे लाइक इतनी यूनिट क्विज 1 के लिए, इतनी यूनिट क्विज 2 के लिए?
Yes. It will be divided. Unit number 1 and 2 are for quiz 1. Unit
Okay.
number 1 and 2 is for quiz 1. Unit number 3 and 4 is for quiz 2.
Okay, sir.
And this cementitious material and filler material, it will come in quiz number 1. And then mixed design, workability, compressive strain, and other test will come in part C. This will come in quiz 2. So in part, the quiz 1 is based on the cement aggregate, okay? And quiz
Okay, sir.
2 is based on the your concrete, okay? And I will share you just now. I will share on your WhatsApp group this question answers, that is MCQs. You will study from them, and then online quiz session will be there. You have to answer online. As you are joined, that also I will take. Okay, that will come under the performance. Yes. Your performance. So
Okay.
just now I will share you the MCQs. You will study, and then based on that, I will share the quiz for unit number 1 and 2 today or tomorrow. Okay, so you have to complete.
Yes, sir.
Okay. Any more question you have? You can ask with me. Already we are covered 12 experiments. Only some 5 to 6 experiments are remained, and that's our concrete. Few of them we are already for the slump and compressive strain or videos already we have seen during the classes. Once again, we will go through that, and also how to do the mix design calculation using spreadsheet. That also I will explain to you sometime when we will get time. Okay. So best of luck for your examinations are there. Be prepared for quizzes also. Okay. Thank you. I will share just now with the